Welcome to Ask and Learn.
Hello, in the question we have given that an 12 kg block. So let us call this as M1 is equals to 12 kg. So this block will have a velocity of V1 which we need to find out. So we will come across when we will proceed in the question. So and let us call this M2 as 23 kg. So this velocity of this block will be V2 which also we need to find out. So this two are resting on a horizontal frictionless surface. So between these two blocks, we have one spring which is squeezed. So this spring has a spring constant of K is equal to 1330 Newton per meter. Now the spring is compressed by, so the compression is given, that is 0.141 meters from its unstrained length and is not attached permanently to either of the blocks. So if this is the condition, so after compression, if we release it, so these two blocks will start moving with some velocities. So what that velocity is we need to find out, that is V1 and V2. So in order to find that, let us use first the law of conservation of energy. So we will use the conservation of energy over here. So according to the law of conservation of energy, initial kinetic energy plus the spring potential energy, that should be equal to the final kinetic energy plus final potential energy. Now finally the spring has been will remain in unstretched condition, so this will be 0. Initially the blocks are at rest, so this kinetic energy is 0. So from here we will get half kx square is equal to half m1 v1 square plus half m2 v2 square. But now see this equation. In this equation we have two unknowns. See, v1 is not known, v2 is also not known. So this problem is not solvable with this equation. So if I have two variables, I need two equations. So two equation will come from the conservation of momentum. So if I use the conservation of momentum over here, so I will get m1 v1 is equals to m2 v2. Because see, initial momentum will be 0 and final momentum will be m1 v1 minus m2 v2, because one of the block will be moving in the opposite direction. So and if we equate, we will get this. So from here if I calculate v1, so v1 will be equal to m2 by m1 times v2. So v1 will be equal to m2 is how much, 23 divided by 12 times v2. So v1 will turn out to be 1.91 times v2. So this is v1. Now we will plug this v1 in the conservation of energy part over here. So then my equation will turn out to be half kx square is equal to half m1 v1 is 1.91 v2 square, sorry, the square is out of this bracket, plus half m2 v2 square. So now we will put the values. So see what we will get. So we will get 1 by 2, k is 1330, x is 0.141 and square of this, that is equal to 1 by 2, m1 is 12 into this will be 3.6481 v2 square plus, I'm writing it down due to lack of space, so it will be half m2 is 23 into v2 square. So this half will get cancelled from every side, from both the sides. So and then if I solve this, I will get this as 26.44, that is equal to 66. So if I calculate this, this will be 66.66 77 V2 square. So from here V2 square will be equal to, I am dividing both the sides by 66.77. So that turns out to be 0.39. Now taking square root on both the sides. So V2 will be equal to square root of 0.39. So V2 we will get it as 0.62 meters per second. So this is the V2. Now V1 we have calculated. V1 is 1.91 times V2. See. So V2 we will plug over here. So what we will get, V1 will be 1.91 times 0.62, which turns out to be 1.818. So 1.18 meters per second. So this is V1. So I am writing here the final answer. So V1 is 1.18 meters per second and V2 is how much? 0.62 meters per second. So this is the complete answer. I hope you find the solution useful. Thank you.